Hello. Hi everyone, good morning. Hope everyone's well. We've got a really great panel today, and I'd like to start by allowing everyone to introduce themselves. My name is Christopher Nicolas. I'm a director at TBH.
Hi Nicolas. My name is Yanni Spanos, Vice President Sustainability Expo City Dubai.
Good morning, everyone. I'm the Associate Partner of Sustainability at Plus Impact and Head of Climatize.
Good morning, everyone. This is Gayathri Udhay from JLL, Principal Sustainability Engineer.
Good morning, everyone. Iman Abi Saab, Technical Director, Mott MacDonald.
Good morning. Farouk Jivani. I'm the CEO and founder of Zeroe.
Good morning, everyone. Mohamed Amer, Managing Director with ICC MENA.
Thank you very much. We got lots to get through today, so bear with us. Lots of good questions. Welcome to our panel on sustainable alternatives. The construction sector is under increasing pressure to cut embodied carbon. Our expert panel represents innovation in engineering, regulation, sustainability strategy, and real estate. Let's explore materials, systems, and mindsets driving this change. I'd like to kick off the panel first to discuss carbon-intensive materials, viable alternatives, and green materials. My first question, which construction materials contribute most to embodied carbon in the region, and what are the most viable alternatives considering our climate in the region and performance expectations? I'll start with you, Iman.
Thank you, Chris. Happy to kick off. To answer the question of where the bulk of carbon is, it's good to start with a quick refresher of what embodied carbon is so we can know what we're talking about here. So everyone have heard that many times. The building sector contributes to 40% of global carbon emissions, and half of that is embodied carbon. The other half is operational carbon due to operational energy emission, water, and so on. So when we talk about embodied carbon, the majority of this, more than 50 to 60%, goes to the building structural materials. And here we are mostly talking about concrete and steel, which come from very energy-intensive processes to manufacture them. So if we focus on concrete first, which is the bread and butter of our Middle East industry here, and if we look at a typical 1 cubic meter of concrete, and we start breaking this down to see where embodied carbon comes from, we will find out that the majority, 58, 59%, comes from cement, and 19% comes from steel, and the rest is obviously water and aggregate. And whilst the aggregate forms most of the volume, it only contributes to only 3% of embodied carbon. So we need to put our effort into the cement and the steel. And if we start with cement first, probably looking at how the process of manufacture works like. When we manufacture cement, most of the carbon comes from the kiln operation, maybe 20%. Another percentage comes from the thermal energy, and the rest comes from the chemical decomposition of limestone into lime. And whilst we can reduce carbon by substituting fuel, for example, in the thermal energy process, we are still relying heavily on carbon capture in order to control carbon in the cement industry. Let's not forget that cement is contributing alone to 8% of global emissions. So we've got a lot to do with cement. And so what are the solutions here? And I'm going to focus on what we have in our industry now, going from the simplest to the most advanced and complicated. The simplest solution answer is around specifying maximum cement content in mixes. Obviously, our contractors try to increase cement to control flow and productive, basically ease of working with cement. So one easy way is to specify maximum cement content. The next one, which is quite heavily available in our industry, widely used, is cement replacement. So this is where we remove partially the cement. We replace it with fly ash, microsilica, or slag. But this is also coming from energy-intensive processes, so probably not the ideal material for us. The next one is geopolymer concrete, and this is also used in our industry, and this is where we replace fully the cement with fly ash and slag, plus an alkali activator. So this has been proven to reduce carbon substantially compared to the cement replacement or traditional concrete, but also give us increased durability. So we are using it more extensively in harsh environment, marine environment, and so on. The next one that we can talk about is back to carbon capture. You've probably heard of Carbon Cure. This is a groundbreaking innovation in our Middle East industry. We don't have enough time to talk about it, but this is essentially capturing the carbon and injecting it back into the fresh concrete to reduce the carbon. Quite scalable and a big one to hope for, that is going to reduce carbon substantially. And if we look more towards the future, of course, the industry started to think about replacement of cement. One of them is calcined clay, you probably heard of, widely available in our nature, but obviously not commercially yet used, bioconcrete, and so on. So that's the journey of the cement. Aggregate, in the UAE, we have been using recycled aggregate from the waste of the construction material, and this is working very well. And obviously, this has impact on reducing environmental impact and supporting the circular economy as well. Finally, the steel. The steel is mainly two things that I'm going to touch on. Using recycled steel content. We've been doing very well in the region. Earlier, I think Jason touched on AGSI, which is the first net zero company or industry in the UAE to manufacture steel using almost close to 100% recycled steel. So this is really amazing. And the second one is green steel. And when we think about green steel, this is basically about changing the process using green hydrogen. For example, we can mention the partnership between Masdar and M-Steel, where green hydrogen is also being used to replace natural gas, basically, in the process. We've got also the renewable energy and the electric arc furnace. This is going more into the detail of fabrication, replacing the basic oxygen furnace, and it's also been used locally, again, by AGSI. Doing this with maximizing the recycled content, we're coming to a substantial reduction in the carbon that could go all the way to 85–90%.
Okay.
I'm going to stop here, maybe.
But a significant amount of issues surrounding cement and steel. Engi, comments from yourself?
Well, I think she got it all covered. There are a few other items. Yes, cement and steel are the major players, yep, right? And that's because we rely on concrete and steel as the prime structural components and materials in our buildings. But there are other materials as well. You know, we can look at, for example, the tiling right here, the ceramic tiles. Aluminum, although it's lightweight, but it has one of the highest embodied carbon content as compared to even steel. So it's, while yes, our focus should be on the concrete and steel due to the, let's say, the weight that is, or the amount that we consume, there are other replacements that we need to look at and focus on. And how do we do that? It's, again, looking at, we don't have to reinvent the wheel. So with aluminum, there is the recycled content aluminum that we can, you know, remanufacture, reprocess, and produce for us to reduce the the carbon footprint. But what I would like to highlight is, yes, while there are a lot of alternatives out there, I think our challenge as well as our main issue when we come to tackle sustainability is that we're not looking at it from a holistic point of view. So yes, while changing perhaps our methods to produce green cement versus Portland cement, our reliance on geopolymer concrete that is now being used with 3D printing and the like, it's a great advancement. We're not looking at its counterpart. Have we looked at how much embodied energy is each offsetting? Because the amount of embodied energy could literally negate all the savings that you have done from a carbon perspective. And just recently, I was actually speaking to one of the local suppliers here, and they were telling me that it's actually, well, cheaper, one, for them to produce virgin material products than for them to recycle. But even if they do want to go that extra mile, it actually, what they have noticed is that the embodied energy goes up by at least 20 to 30%
Wow.
for them to, you know, produce a low carbon product, which kind of conflicts what we're trying to do.
The cost-benefit ratio has to be
exactly,
overcome.
Exactly. And it's not just that. We need to look at it again. What we also fail to do is explore the different options and weigh in, okay, do I go with a 3D printing construction method, or do I go with a green cement and recycled steel as opposed to that? Which options should I guide my client, or is there a third one? The thing is, you might find that perhaps based on the composition and the manufacturing decisions that went into play, that just going with your typical green cement and recycled steel could actually be more environmentally friendly than a 3D printing or precast, or vice versa. And of course, there's a cost element.
So a solution bespoke to the actual project with
Exactly.
consideration.
Exactly.
Gayathri, I'll follow up. What are some often overlooked considerations that influence the actual carbon footprint of these materials?
Thanks, Chris. Rather than just highlighting one or two factors as being overlooked, I completely agree with what Engi just touched upon, which is what is lacking is a holistic approach towards the environmental impact of a material, especially when material selection is happening. So for years now, the industry has been driven by relatively simplistic metrics, such as, let's say, recycled content or local sourcing, etc. While these are important factors as well and definitely contribute to decarbonization, I believe these only scratch the surface of the issue. And I also agree when we spoke about, for example, the cement replacement. The replacement of cement as fly ash and the slag could have more embodied carbon than the cement itself, right? So how do we document that? I think with this global momentum towards net zero and more and more developers having ambitious decarbonization targets, I think we need to have a broader lens. The gap, I feel, is the life cycle thinking. So tools such as environmental product declarations, they document a broader impact of a material in addition to the basic attributes. So it captures the emissions starting from cradle to grave, as we might know. So it captures the raw material extraction, it captures the manufacturing facilities, energy efficiency, water use, installation impact, and end-of-life carbon, everything in a verified way. So unfortunately, this kind of data is not being widely adopted during the decision-making process. So I think to have a transition from a checklist sustainability to impact-based, as you started with, Chris, I think tools such as EPDs backed with a life cycle assessment should be widely used. So I think this might effectively decarbonize buildings.
And that ties back into what Engi was saying before, that we have to consider the material in light of the project.
Exactly. Yeah.
Okay. I think the next question may have already been answered. When we talk about green concrete or low emission steel, what's the actual reduction potential in embodied carbon? Is the impact significant enough to justify wider adoption? I think, Engi, you touched on that one solution may create another problem.
Yeah. No, absolutely. I mean, if we're going to take it at face value, you know, considering all the parameters are aligned with our ambition and goals, green cement could easily offset somewhere, realistically, I would say somewhere between 40 to 60%, but it could prove all the way up to 80 or 90%. Similarly for steel. With steel, I would say 75% to 90% is where you would look at it. But again, that is if you're taking it at face value. Now come to the actual manufacturing, the process. Are you using a blast furnace? Are you using an electric furnace? Are you looking at how much pre-consumer versus post-consumer recycled content? Look at the whole process. So it's, again, we need to look at step by step, the whole life cycle assessment of every single ingredient that goes in there. The transportation plays an element, for example. You know, and I think one of the also important things to think about is that we touched bases earlier about how viable are those solutions. I'll give you an example, a real-time example of one of the projects that we were working in. It's actually in Abu Dhabi, and it was going for net zero energy, carbon, whatever you want. And the client was so persistent. I need the life cycle assessments, I need this, I need that to prove that, you know, we're getting the carbon reduction that we are saying, and we've done our homework. But by doing our homework, we found the following. While we were specifying, or we were about to specify, 80% recycled steel content, because some of the suppliers were saying we can achieve 80 or even 100% recycled content. The reality of things is that when we went to the factories, they said that impossible. We will never be able to achieve it. If you want to push your boundary, realistically, we can give you 8% recycled content. And I'm like, what are you talking? 80% to 8%. They're like, if you are willing to pay a premium, that's because I have to activate a whole new line for you. Okay, we can talk about 12%. I'm like, that's not enough. They're like, we can push it as maximum as 40%, but cost, remember the cost will play a significant factor. And when we went back to the client, they were like, no, this is not going to work. So we had to look at different alternatives to make up for the steel, which in a market where we claim that we can achieve 80 to 100% recycled content, we're actually more realistically at 8 to 12%, which is such a shame because obviously you would expect more. But it's also, I get it. You cannot just produce a whole new line for one client.
That's the big balance.
And that's where the movement needs to happen. You know?
And I'm really glad that you spoke about some of the, you know, real experiences, which brings me to my next point, that we understand real life lessons from the market. I'm pleased to have Dr. Spanos with us here, and he'll provide us some insights on Expo. So Dr. Spanos, given Expo's portfolio, could you share insights from any studies undertaken to understand the specific technical challenges you face in your buildings, and what were some of the key findings?
First of all, it's nice to have this discussion and agree with all of you. I think we have the same findings, one way or another. And it's nice to listening what the consultants say, and we're speaking with suppliers as well. But the most important for us was to understand what we have to achieve. Yep. Because without having numbers or what the impact or will be. If you see globally, the two numbers are coming rise about how much carbon is per square meter of GFA in buildings. In UK, they're using the Low Energy Transformation Initiative target of just below 1,000. In Singapore, they're using values between 1,500 kilograms per square meter. In Expo City, we have the privilege to have data from Expo 2020. As part of that, a lot of carbon collection, carbon dioxide measurement collection has been done, and it was a target of 40% on structural elements to be reduced, which has been achieved. Based on the data we have and additional studies we have undertaken the last year, we believe that the embodied carbon of a building, not measuring just the structural, but building services, construction emissions, transportation, it will be around 1,200 to 1,400 for a building that is designed currently as Expo City. And that means a building that has no basements, no extensive parking areas, no swimming pools, no. Based on that, and considering what is approximately the energy consumption of a new building for the next 20 years, 25 years, as we stand right now, the embodied carbon, which is upfront carbon cost to the building, can be about 40% of the overall energy carbon that consumed for the next 25 years, which is high. However, that's the tricky part. We're looking also to develop mid-rise buildings and high-rise buildings, which is going to require the parking spaces, swimming pools, basements, as everything that is built within Dubai currently. And that was the study we have undertaken last year. So it seems the carbon emissions then will be increased even beyond 2,000 kilograms CO2 per square meter as a baseline based on 2021 building regulations.
And Dr. Spanos, I see that there's lots of apartments going up there yesterday. I went for a bike ride around Expo to do my research.
Yeah, we have a lot of apartments.
I saw a lot of apartments going up, so you've got a lot of challenges ahead.
A lot of challenge, but what the challenge means, and that's my challenge to understand as vice presidents of a portfolio of buildings that wants to focus on decarbonization. Then if we consider the GFA, because within the GFA is where we're consuming energy, suddenly we're finding out that the embodied carbon, the upfront cost to a building, is about 55%. So the carbon emissions is more than the electricity emissions. And that's even, the next thing is more challenging. Our grid will be decarbonized. Like the next 25 years, we're expecting from DWA to add more renewables, to add the hydro plant, so the carbon emission electricity will reduce. And if you consider that as part of the overall, we may end up that buildings that are built right now in Dubai may have 70% of the carbon emissions already upfront in the balance sheet. And that's the biggest challenge I see.
So a lot of lessons, a lot of lessons.
Yeah.
Farouk, how do you see those lessons translating into the broader market application across the region?
So I'm just going to try to connect kind of what I hear, right, from like what we've talked about. Data.
Yeah, you've had a lot of people
there's a lot
building up to you.
Yeah, I mean, there's a big build up to me, but I think there's, I think if you take it, it's data.
Yes.
How do you collect all of this data from when you start designing a project, conceptualizing that project, carrying it through the life cycle of actually building that, that building or that asset, and then managing that asset for 20 to 25 years and getting this full picture? I think that's a massive kind of challenge that I would say all developers are going to face across the region. And I think there's a lot of disconnects because at different phases of this journey, we do a lot of work. We have engineers in place. We have architects in place. We collect a lot of data. We might then pass it to a procurement team. We might be getting environmental product declarations, or we won't. But where does this how do you process all of this information and position people to make decisions to actually manage this journey, right? And I think this is a massive challenge.
Okay. Dr. Spanos, just to come back to you about Expo, because obviously some great lessons. Expo's publicly emphasised sustainability and carbon reduction. What strategies and initiatives are you currently implementing to address the decarbonisation of embodied carbon emissions in your current real estate developments?
I'm smiling because you added part of my answer, data collection.
Oh, did it?
It's pivotal, isn't it?
Okay, first of all, we want all our new buildings and at the design stage and construction, the consultants and the contractors to be able to provide 60% of the cost environmental product declarations. So we should know what's happening within our buildings. The second thing is, as part of the decarbonization roadmap, we're aiming for a 40% reduction in embodied carbon by 2030. If it's achieved, I really don't know currently, because we see a lot of challenges within the market, and especially the supply. The supply chain is not there. Even if we're discussing with global suppliers of concrete and steel, different challenges they have that don't have the products ready, or even these local products is not where it's supposed to be. We're trying to reduce it to 20% by design. The next thing is we're developing our software, because you cannot manage without data. And we're developing a software we can collect now all the data associated with construction. And that means anything from transportation of labor to fuel, water, embodied carbon, all the emissions. And of course, we're speaking with the supply chain, and the supply chain to understand what is the action plans. Because I can speak to any concrete supplier, but he has to tell me also what's his action plan, what he's trying to bring in the market.
Thank you for those insights, Dr. Spanos. Moving on, I'd like to discuss budgets, supply chain, and regulatory influence. I'll start with you, Mohamed. Do rating systems, regulations, and building code, from your perspective, support or hinder the shift to low-carbon materials?
Thank you very much, Chris. I would first also like to resonate and relate to everything that has been said. Representing a company that is primarily involved in, ICC is a leading global source of building codes and standards. So we have a moral responsibility when it comes to anything that has to do with building safety. And it starts with the heart of any sustainable building lies within its building codes. And then comes the whole bunch of ancillary services related to testing, inspection, and certification of building materials. And I think, what has been discussed so far related to how can we monitor throughout the whole life cycle of not only buildings, but building materials, end to end. And I think it has to do a lot with what we call product traceability, which is probably something that needs to gain traction. EPDs, life cycle assessment reports, it all comes into the mix. But from a regulatory perspective, we as a non-government organization, we work closely with authorities having jurisdictions, and we call them demand drivers. And we work with the private sector, consultants, contractors, manufacturers, standards development organizations, in order to ensure that the building codes that a lot of jurisdictions in the region, their building codes are based on the I codes. So there's a lot of harmonization, a lot of work that we do with them. And I can just give a very quick example and very famous examples, the plumbing, mechanical, private sewage disposal codes that pretty much regulates the disposal systems, taking care of the welfare of the occupants of the buildings. It's not only we have a saying, or there's also, sometimes a misconception. People think buildings are safe when they're structurally intact, but they don't know that there's much more to it. Fire safety, indoor air quality. We've had a case study where we were testing the performance of employees in companies and how the indoor air quality in terms of the chemical emissions affect their performance. And it may be a surprise for many people that the tiles, the paint coming from or the chemical emissions coming from the paint, when this is all changed and is replaced with more compliant materials, it increased the performance of the employees by 33%. So imagine how this would be in schools, for instance, with students. I may probably tap on more related to the compliance pathways that we offer for building materials, maybe as we proceed with the discussion. But one thing that I want to mention is going back to the traceability and how sustainable it's no longer about wet or dry construction. It's no longer about whether we use concrete or steel. It's about what kind of concrete, what kind of steel. And I think, I'm not sure who said that, but there's a quote that says, transparency is the new color of sustainability, not green anymore. The more you are transparent, the more you know what we're doing, how we're doing it, and how long we're going to continue doing it. This is where we start to achieve carbon neutrality across the whole spectrum or life cycle of buildings.
Fantastic. Gayathri, any comments there?
Yes, from the consultant's perspective, I can just add to that. I think definitely regulations, rating systems, and codes are supportive of the transition into the low carbon materials. I would even say that they have been the key drivers of change in the industry over the years when sustainability has been gaining traction. Specifically, when we talk about the rating systems that are adopted widely in this region, such as Al-Safat or Estidama and LEED, they've been pushing boundaries when it comes to sustainable material selection, especially, and largely influencing the codes in a way, and also setting market expectations, I would say. But I think what we observe is that major developers go over and beyond the basic bare minimum set in the codes. But largely, the projects are still complying with the minimum requirements that are regulatory in the region. So I think for true transition to happen, the codes and regulations could, if it adopts more ambitious targets, such as setting carbon limits or probably mandating life cycle assessment or something that could really accelerate
to lift the minimum
sustainability performance across, I believe.
If I can add a quick one, I think from a consultancy perspective, I think in a way it's safe to say we're all on the same page, right? But I think the main regulations that need to come into play needs to be on the supply chain, right? Because there are a lot of times where we want to go beyond, but either the infrastructure is not there, the material is not available, we need to grab things from global suppliers, increasing our transport emissions. So I think we're all set, but we need the tools. We need to be equipped with the materials, with the infrastructure, with the right mandates. So I think part of this transition needs to focus on actually greening that supply chain.
And look, that brings me right into my next question to Farouk. How does the fragmented supply chain and project budgets limit the adoption of sustainable alternatives?
So I think, well, one, project budgets are often set before we actually decide how sustainable
the horse is bolted, right?
We want to be, right? Or how, and that's a problem. When you're looking at a project level, I mean, many of the developers in the region here have, 80, 90, 50, 60 projects running simultaneously, right? If you clubbed all of that demand together, you could drive change across the supply chain.
Yeah, absolutely.
But everything is being looked at like, we launched a new project.
Singular.
This is the budget. Here, let's try to make this one sustainable. We're marketing this one as sustainable. We're marketing this one for profitability. We're marketing this one for luxury. But they're not clubbing this entire strategy together, right? And then driving change through this, the amount of construction, the development happening across this region is massive.
Yeah, clearly working at a development level is going to capture a broader range.
Yeah, and I think that's kind of one key step that could be taken, right? And I think large developers need to look at it and say, we have a lot of power. A lot of this, I get a lot of conversations where it's like, well, we can only get what we can get from the market. And so, you have all the power to dictate what the market does, right? And I think starting at that standpoint and saying from the very beginning, these are our targets, and we're going to drive our entire value chain to deliver this, that's super important.
Yep, sure. Further to the discussion on regulation, I'd like to hear more about institutional and code-based support. So from Mohamed and Iman, to both of you, how are structural engineering institutions and code-setting bodies evolving to support lower carbon design and materials? Mohamed, I'll start with you.
Yeah, so going back to the fact that in the MENA region, the authorities having jurisdictions are we call them the scheme owners or demand drivers, because everything comes, the mandate. It's a centralized model as opposed to like in the US where the codes are being developed as decentralized. But the private sector has a major contribution as the people who drive the innovation, and then for the authorities to regulate. So if you look at the Dubai Building Code, if you look at the Saudi Building Code, the Gulf Building Code, the upcoming Oman Building Code that are based on the I codes, creating more harmonization, you'll see that there's a shift towards performance-based design. And when I say that, going back to the materials, the part that I wanted to highlight, if you look, for instance, at offsite construction as a new methods of construction, the components used like SIPs or trusses or wall panels, in essence, they are the classical way of building structures, but the way they're designed, that they are, or the way they're manufactured, that they are using less, like producing less waste and using less energy. And at ICC, we provide a solution that provides or that shows proof of compliance to these building codes, so that when manufacturers are seeking market access and they want to use their systems, they need to get approvals from the authorities. And the classical way of approving materials is backed up by standards, but some systems or materials or products are performance-based, as I said, so they have to comply with the overall intent of the code.
Sure.
And this is where third-party evaluations, again, going back to how can we make sure or confirm that whatever is being produced, low-carbon cement and concrete, or specific self-curing admixtures in concrete, we need to back them up by compliance reports that gives peace of mind for the authorities, that can be specified in projects by consultants, and probably in the future can be standardized in the codes. So it's a full circle. There's a big part of it related to capacity building. You have trainings, you have plan review, you have standards development organizations working together in order to come up with these standards that can cater to such new technologies in the market.
So Mohamed, can you provide some examples of recent ICC initiatives in the region that support and reflect this shift?
From a code development perspective, as I said, I mean, we're currently working with the Ministry of Housing and Urban Planning in Oman to develop their building code. And a lot of it is, or there are a lot of provisions that are performance-based that allows for alternative use of materials or alternative design. But specifically on systems that are being adopted in the market. You have, for instance, people may have heard of this, the void slabs as opposed to the solid slabs. It uses less concrete without compromising the structural integrity of the buildings. So this is one example, very simple, it could sound sophisticated, but it's all made out of recycled plastic, but it still requires proof of compliance. And it's not specified in the code, but if you open Dubai Building Code, you'll see in the very beginning of the chapters, they have this window for alternative use of materials. So this is one example. And then I gave the example of the self-curing concrete or the admixtures that uses less water. Therefore, it's like a water conservation advocate to cement, and it increases the durability and the strength of concrete. And they're also being supported by the authorities to use such systems that are more carbon neutral, or at least achieving near zero emissions. So yeah, I mean, we can go more and give more examples from offsite, from 3D concrete printing, up to not only the walls, but even the mixture that's being used in constructing the walls. And these are all, as I said, technologies that eventually gets regulated by the authorities in order to become mainstream or to be widely used across the region.
Sure. Iman, from your perspective, from the Institution of Structural Engineers?
Yeah, sure, Chris. But just before I answer this one, I think we spoke about material alternative, we spoke about legislation and supply chain. One thing that we didn't speak about is how early we start thinking about carbon in the life cycle of the project. And it's very important to recognize that the biggest impact is really at the early concept, how we conceptualize our project, thinking about height of floor, buildings, do we knock down what we have and rebuild, do we reuse what we have, how many columns, what's the grid spacing, and so on. If you think about this hole here, if you maybe stick 4 columns in the middle, you could cut down carbon by 20%. Obviously, it won't be looking nice, you won't see us as clearly, but there are ways really to impact the most carbon early in the stage of design. And the most impact we do, from my experience, is working together, all the stakeholders, client, consultant, all the parties, different disciplines, thinking about the systems and everything else that goes along. So back to the Institution of Structural Engineers, in terms of the global, at the global level, our institution is leading in the space of carbon reduction. There are lots of guidelines and support in terms of calculating carbon and managing carbon, lean design, circularity, zero waste, and so on. The institution also engages communities and working group to think about carbon and to discuss this. There also, recently, the institution has launched the status of chartered environmentalist engineer in addition to the chartership level to recognize those engineers that are making a difference in the sustainability space. And there's also the one that I mostly enjoy is the yearly structural awards, which award projects that obviously embed the sustainability principles. Yeah.
Yep.
On the regional level here in the UAE, and I am continuing from your 1,200 kg CO2 per square meter, and the transparency. We are leading an initiative for the last 2 years as a regional group that we are quite passionate about. And this is about benchmarking carbon, embodied carbon. So we've been connecting with various stakeholders in the industry, contractor, developers, consultants, and so on. And we've been collecting data. And we have published a paper in the ACI conference around our findings. And it's all about, you'll be surprised, Chris, how difficult it is to get numbers and data on where we are in terms of embodied carbon per square meter in our industry and how are we progressing towards this net zero. Yep. So this task, although it seems easy and straightforward, it has been very challenging to collect the data. So we're in a space where we believe we need to work harder because our average now is not looking great towards the net zero 2050, 2040. But it's important to keep the effort.
But Iman, that's obviously going to require public government support and developer support, obviously. Which leads me to the next question. Obviously, developers need to genuinely buy in and not just only the public sector. To Gayathri, how are developers currently viewing embodied carbon? Is it still a checkbox for reporting, or is it influencing real-world decisions? And maybe Dr. Spanos can jump in there.
There are a lot of developers within the UAE, but I don't believe all of them are focused on embodied carbon. As part of the life cycle carbon of the buildings, we working with the World Life Cycle Assessment of Royal Institute of Chartered Surveyors, which is, I think, have data, and I'm saying about structural engineering because we had the training last year, and one individual from structural engineering was there. But the most important for me was we had leading contractors and leading developers as part of the attendees, and we're looking forward to have another session. So follow our webpage. There's going to be some news about the training in October, November. We need to see and find the best opportunities. The regulation will help. The Dubai regulation edition of 2021, we can say that has reduced the emissions of structural steel of concrete about 30% with GGBS, and energy consumption about 35% with the new standards they have added. So, but it's not only that. As part of the opportunities we're looking, one of the good case studies is the Al Waha project. It's almost 290 units. But instead of demolishing the old exhibition spaces, we went and actually we're going to reuse all of them to remodel them and make them from commercial and exhibition center to residential. Now, why I'm saying that, because there's a lot of stranded assets, and others could use this kind of notion, but taking the calculations and what we can achieve, we can achieve 65% embodied consumption reduction of the overall project emissions, which goes beyond our standards. And if we want to put it in trees, because some people like to put it in trees, it's going to be about 65,000 trees. That's almost double the area of where the residential buildings will be.
I can see that they're underway at the moment. They're being developed right now, which is good news.
They are actually. But look for opportunities. Unless the building regulations open more to alternative materials, which agree with you, they have the clauses, but speaking with suppliers, this very lengthy process to pass through something. It's more than a year, it's probably more than 2-3 years. And then are we going to find challenging to reduce our embodied carbon by 2030?
Sure.
Very challenging. Of course, design is one, and I agree. We can achieve 20% reduction by design. That's what we found out with our projects. But that's the limitations. Beyond that, we have to think about alternative materials.
Gayathri, your comments?
Yes. Just to answer the question directly, checkbox is not the way to go anymore.
No, not at all.
Definitely, developers are leading the way, such as Expo, and many developers are leading the way by embedding requirements, including requirements for sustainable materials into their design guidelines to start with. So if we talk about the Net Zero 2050 and post-Expo and COP, with the kind of initiatives that the government has launched recently, I believe there has been talks that reporting could even become a mandatory requirement shortly. So reporting in the sense, just to put things in perspective, of the scope 1, 2, and 3 total emissions, for a developer, scope 3 could constitute approximately 70% to 90% of their emissions, because
wow.
Scope 3 is majorly, coming from products and services, which to the developer is buildings and construction. So from the construction, there's going to be at least 70 to 90% impact on the total emissions. So just by looping what Engi just shared about the savings that we could achieve by targeting low carbon steel and concrete of up to like 40 to 60%, which on an average, if we look at it, might have an overall impact on the emissions that will be reported by a developer, up to 15% at the minimum, wow. Which is significant. Sure. And even to achieve that much impact, I don't think checklist would work anymore. And consultants such as us, we work with developers by studying their portfolio performance, benchmarking against the industry standards. We come up with a shopping list of items that could be standardized for the, across the portfolio. And all these are done as a start with whatever visibility we have at the moment, sure. About the market and the availability of sustainable materials. Just to answer that straight, I think definitely already market is shifting towards more performance-based approach and going more beyond a minimum set. Yeah.
Okay. Farouk, just turning my attention, we've heard a lot about carbon-intensive materials, and I think we touched on it earlier with Engi. What about the production of these materials?
I think renewable energy, when it comes to the production of materials, is
first place to start.
Is the first place to start. Yeah, I think we're still way behind where we need to be in a lot of this, right? And I think it all goes back to the value chain demanding it, right? I think that's primarily where we need to actually start, yeah? I just want to touch on the last question,
please,
if you don't mind,
sure.
Yeah? And if I see where developers are and if they're checkboxing, I think apart from Expo City, you have very skim sustainability teams across most developers.
That's fair to say.
Yeah, I think that's the first step, right? I think they're just grappling with, well, can we even get the management of these developers to understand that sustainability should be something that matters as part of what we do as a business? I think we're super early there. I think when it comes to emissions, you mentioned scope 3 being the largest part of their emissions. Most of them are not measuring scope 1 and 2, and it's a little bit of what they need to be doing. Yeah? So, apart from Expo City, I think we're really far behind. I don't know if it's okay to say that, but that's my view. And I think, that really, there needs to be some serious kind of, steps taken. I think we're I don't think we should be in check boxes, but I don't think we're even checking the box right now because no one's making me put the box on the board and do it.
Yeah, sure.
Yeah?
Sure. Engi? in terms of what you were touching on earlier in the conversation, what about the production of the materials?
So I mean, you said we need to start with, steering away from fossil fuel, for us to produce materials or to any part of our lives, just for the fact. So yeah, renewable energy, recycle or closing the loop on water and waste, all of that plays a factor. So supply chain needs to look at how they produce it, from extraction all the way to its end of life. Where they can step away from fossil fuel, they should. Where they can reuse and recycle, they should.
Yeah, sure.
Where they can explore new innovation for us to achieve both a reduction in embodied carbon as well as energy, they should. And it shouldn't end there. Again, there is a responsibility on the entire ecosystem. And we're not just talking design and construction, because that's one part of it.
Sure.
There's also the larger part of the emissions actually happen during operations. So we need to also tackle that. We need to have the right foundation from design construction, but we need to bridge the gap from construction to operation, educate the operation and asset management teams on how to operate more sustainably,
yeah, of course.
one, and two, even like in terms of retrofits, maintenance, that all plays a role, right? So we need to also consider that. And
full
obviously,
life cycle.
The waste that's being generated and how we can minimize it and so on.
Okay. I've got one more question before I open up for questions from the audience to Dr. Spanos and to Mohamed. Looking ahead, what critical industry changes, technological advancements or collaborative efforts do you believe are essential to unlock faster decarbonisation across the real estate industry? I think Farouk can obviously provide some insights too. So, Dr. Spanos, starting with you quickly.
First of all, I have to say that energy, of course, must be our focus, energy reduction. And I would like to congratulate the Dubai Supreme Committee of Energy for a lot of initiatives that's taken, and we can see an impact in Expo City. Now, in order to be able to scale up a market that, as a supply chain, does not exist or exists very sporadically, I believe the regulatory framework has to start think how to introduce such materials within the future building regulations. But for me, most importantly, is to find a way this type of materials to be able to certify it faster within the UAE. And there is a lot of different systems globally that exist, but when we're trying to bring them here, none of them has UAE certifications. So it's a big challenge.
It all takes time.
Takes time, a lot of time.
Mohamed?
Yeah, I think a lot has been said on that, but there has been a lot of technical regulations coming from the standardization authorities which really governs the manufacturing process or the star rating for system efficiency. But then if you look at the buildings, it's more on the building envelope design. You need to balance both. There's a very famous example of that. If you have an efficient fridge, but you keep the door open, energy is going to be released, and it just defeats the whole purpose.
Yeah,
so
sure.
I think
a good analogy.
I think moving forward, I mean, apart from the new methods of construction, 3D concrete printing, off-site construction in both modular and precast, but in terms of, especially with the intense heat, going above and beyond with the system efficiency in terms of energy conservation, energy efficiency, water conservation, and complementing this with the building envelope design. High performance windows, reflective roofing systems, thermal insulations. This will all put less pressure on the equipments that are being installed in buildings, and at the same time reduce the bills on consumers. So yeah, this is probably one of the aspects that we would see more and more coming in terms of stringent regulations. In our codes, like for instance, we have the International Energy Conservation Code that governs the overall operational efficiency, and the International Green Construction Code setting energy efficient standards. If you comply with the IGCC, going back to the star ratings, the BREEAM, the SAFAT, and so on, if you comply with the IGCC, by default, you achieve silver rating through LEED. So there's a lot of bridging gap between the code's development and the localized or the local star rating system or the building classification system.
That'll obviously lift the bar straight away.
Yeah, it's just a matter of, just to add one more thing, a matter of collaboration. I'm going to turn up the volume on this collaboration.
Absolutely.
Without consultants, contractors, manufacturers,
all collectively working together.
They all have to work, yeah.
Yep. Farouk, any final comments before we close up?
Your original question was, how do we drive that change?
Absolutely.
Yeah, regulation at the top of the value chain and money through the middle. Yeah, capital.
Yeah, of course.
Yeah, that simple.
You've got to motivate the supply chain to get something out of it, right?
Yeah.
Thank you very much, everyone. It's been a really great panel. Much appreciated.